Okay, Harley. So the first thing that we're going to do here before I get into doing homework problems is we're going to talk about the P-series convergence test and the alternating series test. Okay, so the first thing that we're going to look at is we've got the P-series convergence test. And this one's pretty easy. It's as long as you kind of know how it goes. But honestly, series and sequences are something pretty new for you guys, even in calculus. It's a kind of different way of looking at things, and that can be a little confusing at sometimes. So it's like with any new game, you got to learn the rules. We practice, we get better, and then they become real simple. Okay, so I have the summation of n equals 1 to infinity of 1 over n to the p. Okay, this is known as a p-series, okay, because p is that exponent that's on n. And if you can make a series break down into something like this, we can tell fairly easy if it's going to converge or diverge, okay? Simply put, if p is greater than 1, this series will converge. And if p is less than or equal to 1, it will diverge. Okay, such as if I have the summation of n equals 1 to infinity of just 1 over n, and I ask you, is that going to converge or diverge? Well, you've got to tell me what p is to begin with. I know in this particular case, p equals 1, so the series diverges. Okay, and that's actually 1 over n is actually what we call a harmonic series, because it's going to be 1 plus 1/2 plus 1/3 plus 1/4 and so forth. And some of your homework questions did have a p-series in there. We could break it down to a p-series, and so we could easily tell if they were absolutely convergent, conditionally convergent, or divergent. Okay, so that's kind of like all that p-series is. You just got to be able to pick it out. Okay, if we look at the alternating series test, it's going to take a little more effort here. Let's write, I'm just going to switch colors here. If I look at the alternating series test, okay, and once again, you have to be able to pick out that it is an alternating series, just like you have to be able to pick out or see parts of a p-series. The alternating series is pretty easy to see. If we have the summation of n equals 1 to infinity of -1 to the n times 1 over n, okay? And if we were actually to see what was going on with that and we were to input the numbers, we would wind up getting -1. Then we would get plus 1/2, minus 1/3, plus 1/4, and so forth. Okay, now that's an alternating series because that sign does alternate between positive and negative, negative and positive. This particular series right here, this is known as the alternating harmonic series. Okay, and of course the harmonic series is just a special p-series as we saw up there. So let's look at forms of the alternating series that we could have, because part of the hard part is actually picking out what these things are, because you've not ever really looked at these types of things before. So it's hard to be able to just look and see. Okay, usually the form of the alternating series is going to look something like n equals 1 to infinity of, like we had before, -1 to the nth times some function a to the nth, okay, times some sequence there. And then we also have, it could look like the summation of n equals 1 to infinity of -1 to the n plus 1, which that's the same thing. You're counting that by ones in that summation. So n is increasing by whole numbers, 1, 2, 3, 4, such as that's increasing by 1. All they've done is go, okay, well, we want to start with -1 squared instead of -1 to the first power, and that is times a to the nth. Of course, both of those a to the nths right there need to be positive sequences. The sequence will be positive. And you know that a sequence, the difference in a sequence and a series, we have that summation. We're adding up all the numbers of the sequence. The sequence is where I just listed. If I wanted the sequence of 1 over n, and I said 1 to 5, that would be 1, comma, 1/2, comma, 1/3, comma. We're not adding anything up. The sequence is just a list of numbers. The series has that sigma in the front, that capital sigma. That's what that funny looking E is. And it is actually adding those things up. That's the summation of those things. Of course, you know that because you've dealt with integrals, so you know what a summation is. Okay, so in order to be a convergent alternating series, we've got a couple of things have to be met, right? And you've actually worked with this some. I saw where you had made some notes on your homework where you were talking about the alternating series test. Okay, so number 1, it must pass the divergence test, which is the limit as n approaches infinity of a to the nth will equal 0. Okay, it can't equal 1/3. It can't equal 2. It can't equal -10. It can't go to infinity. It can't go to a negative infinity. It must be equal to 0. If that limit of a to the n, and what that means is we strip off that -1 to the n or the -1 to the n plus 1. We strip off whatever is causing the series to alternate, and what we have left is a to the n. We take the limit of that, it has to equal 0. That's the first criteria that it must meet in order to converge. And the second one is simply that a to the n plus 1 must be less than or equal to a to the n, which means in the case of that alternating series that we had up here, the -1 to the nth over 1 over n, and I'm actually going to work that in a minute. Let me just work it, okay? So if we're looking at that original, we're looking at the original alternating series problem that we had up there, which was, so I want to know, does, and I'm just going to write a question out, the summation of n equals 1 to infinity of -1 to the nth times 1 over n, does it converge? Okay, and I'm just asking, does it converge? I'm not asking if it converges absolutely. I'm not asking if it converges conditionally. I'm asking just if it converges or if it diverges. Okay, so let's try it out. Number 1, I have to determine what a sub n is. In this particular case, I strip off the alternating part, which is the -1 to the n, and I've got a to the nth equal, or a sub n equals 1 over n, right? So I'm taking the limit as n approaches infinity of 1 over n, which is going to equal what? That equals 0, because what happens as n gets bigger and bigger and bigger and bigger and bigger and bigger, what's happening? We're getting closer and closer and closer and closer to 0. It starts off with 1, then I go to 1/2. Now remember, this is just the limit. This is not asking you the series as what's happening to 1 plus 1/2 plus 1/3, that kind of thing. It's saying, what does this function do? 1 over n. As x gets bigger and bigger and bigger, or in this case n gets bigger and bigger and bigger, what does that function do? That function gets, its y values get closer and closer and closer and closer to 0. Okay, so that one checks out. So the second part that it has to pass is it has to say that a sub n plus 1 is less than or equal to a sub n. Okay, well, all that means is I have 1 over, or is 1 over n plus 1 less than or equal to 1 over n. Well, yes, it is, because what happens when I add that 1 to it? All my n values are positive. What happens when I add 1 to it? Well, it makes that denominator larger. That numerator's not changed. The bigger the denominator, if that numerator stays 1, then that value gets closer and closer to 0. Okay, so that one works out. They're both, it passes both tests. So that means that this alternating series is convergent. Okay. Let's look at another one with an alternating series on there. We're asking the same question. Does the summation of n equals 1 to infinity of negative 1 to the n plus 1 times 5n plus 3 over 2n minus 7, is that convergent? Does it converge? Okay, does that converge? Of course, we see it's alternating because we have the negative 1 to the n plus 1. Okay, so we need to name an a sub n in this particular case. So we need to, since it's alternating, it has to pass those two parts, those two tests, in order for it to be convergent. Okay, now remember, we're just talking about right here convergent or divergent. I'm not specifying if it is absolutely convergent or conditionally convergent. That's going to come in the next video. Okay. So a sub n will be that 5n plus 3 over 2n minus 7. Okay, so let's look at our tests. I've got number 1. I'm going to take the limit as n approaches infinity of 5n plus 3 over 2n minus 7. Okay, I'm actually going to use L'Hopital's rule here. You guys have probably talked about L'Hopital's. If not, let me know and we can talk about L'Hopital's a little more. But I know when I go to take the limit of this, I can use L'Hopital's or that derivative rule where I take the derivative of the top, I take the derivative of the bottom, and then what's left, that gives me the limit. Okay, so this is going to give me, so pretty much I'm just looking at the coefficients of my variables. So my coefficients of my variables here are 5 over 2. And does that equal 0? Does not equal 0. Therefore, it is not convergent. You don't have to go any further. You don't have to do the second step. We already know the first step tells me it's not convergent, so therefore it diverges. It is divergent. Okay? And that is a short little recap over the alternating series and the P series.